All right. So when we're talking about statics in houses. Oh. I believe my marker's starting to dry out on me. Okay, so statics in houses. Things that we think about sometimes. And I'm going to draw like what looks like the silliest little house. If you have blank paper, draw it on blank paper. If you don't, you don't. But we got this roof, and I don't want to draw the whole rest of the house just yet. But when you build a house, and I'll draw a house that's simple, that doesn't have soffits and eaves troughs, so don't get down on me if you're really into houses, okay? So this is a house. Okay, got our roof. And if you don't know the name for these roof pieces, they're called rafters. Okay, so I'm trying to use proper language here. These pieces are called rafters. And when you go into your attic, you'll see the rafters, and they hold up the roof, okay? Usually they have them a standard distance apart. Everything's done to code. Plywood's on top of it. Then they put the shingles on top of that. But you'll see the rafters if you're inside of your attic, if you have an attic in your home. And they'll be connected up at the top, oftentimes with some sort of a metal plate. Anyway, there are times when something might be hanging from the rafters. Now, really and truly, do we hang things from rafters very often? Not so much. Mostly what we're thinking about is snow on the roof, pushing down on them, okay? But just for simplicity with this drawing, there's something hanging from the rafters. Have I ever lived this situation? Well, not me personally, but my Uncle Terry built a shed in the backyard, and his shed was made just like this, and he didn't hang just any old object. He would hang his snowmobile. He lives up in the Muskoka region, like around the where everybody has their cottages. He does electrical work for people that have big cottages out on the lakes. So like, professional hockey players, stuff like that, right? So he has to have a serious snow machine so he can get out and do service calls in the winter or whatever. So he built himself this shed, and he would hoist up his snowmobile into the rafters of the shed so that he could drain oil out of it easily within a confined space. Doesn't have a huge yard. And he actually built a moat around the outside of his shed and slanted the floor of the shed so that the oil would slick off the floor and go into the moat around the shed, and then later on he would deal with it, or I suppose it would probably cause some sort of environmental disaster. But anyway, it was just made things easier for him, right? Like rather than do it in the garage and make a mess of his garage space. He also is a hunter, so the nice thing about this is that the floor of the shed gets oiled, and then when he has to do some butchering in his clean shed, his food is good, I've never gotten sick, he could hang a deer or whatever from the same hook, and when the blood flows, it will also flow right off now the oiled surface of the floor and into said moat, which all sounds very dark, but honestly seems like a very efficient process, right? So anyway, this is a thing, is all I'm saying. And the sausage you get from these deer is delicious. I'm not criticizing that at all, but everybody's lifestyle is different, Yeah. All right, so here I am in suburbia. I don't live this, but I like to visit and enjoy, right? So we've got this mass hanging from a roof. Now that's great. However, that roof is going to tend to splay apart. Can you see that? And so it was important for him, and it's important for anyone who's building a roof, there has to be something holding that roof together from splaying apart. Now, sometimes people will call it a tie rod. Sometimes we'd call them ceiling joists. I'm going to call this one a tie rod because what you can actually do is you can get steel rods, and you can use little nuts and bolts basically at this rectangle that I'm drawing here. Attach steel rods from one side to the other, and if you tighten up the nuts and bolts at this spot here in the tie rod, it'll shorten up the rods and make the tension increase. And if you want to look for that, you can go to Mapleview Shopping Center. Mapleview Shopping Center, there's some great big vertical posts on either side of the main galleria. And on either side of the main galleria, there is attached a rod on one side of the vertical support post and on the other. And they've tried to dress it up and make it look pretty, but really it's a tie rod to keep the building from splaying outwards. Okay? And you can look up and you'll see the structure. It's all on display. They hang Christmas decorations from it in the winter, okay? And make it look like, oh, we meant to do that. But they needed to do that because it's a structural necessity to keep the building from flying apart. You can see the same thing if you go to cathedrals. there'll be something like that. Now, cathedrals will deal with it differently. Oftentimes, they'll deal with external buttresses, which is a different thing that we're not talking about right now, okay? But that is an external structure that keeps it from falling apart. This is an internal structure that keeps it from falling apart to tie it together, tie rod, okay? Now, the reason I bring this up is that if this force is or this mass is hanging, it will compress the rafters. And then those compressed rafters will also need to get a force from somewhere. They will cause tension in the tie rod. But then people say, well, what actually holds up the roof? Well, and all the gentlemen stand a little taller when we say this. What holds up the roof? The studs, of course, which means something different if you're raising cattle. But in this case, a stud is the support wall that holds the whole thing up, right? And these studs are going to have a resistant to compression force. And like all that is to say that all these things have names and they all have roles. And when I think about the roles that these guys play, and I think about my mass, whatever it might be, whether it's a snowmobile or whether we're really talking about snow on the roof, we could draw a free body diagram for this. The free body diagram would have a force due to gravity acting downwards, of course. If I was having a conversation about the rafters and the forces that they're supplying directly to the mass, if I call this one rafter 1 and this one rafter 2, rafter 1 is going to supply a force out this way. Rafter 2 is going to supply a force out this way. And as soon as I do that, I'm like, oh my goodness, if you were around for the friends carrying feathers argument, this is friends carrying feathers all over again. Agreed? We design our houses based on this. And I said there was an architectural tie-in for this, right? The other thing that I might think about is people say, okay, well, that's what the rafters have to be able to do. They need to be able to supply those compression forces to hold up the mass. But you said there was all this other support structure. The tie rod, what kind of tension, what kind of force is the tie rod supplying? Well, when I think about this, the tie rod is connected to the rafters and keeping them from going out this way, right? And so what the tie rod is really doing is supplying that force and that force to rafter 1 and rafter 2. Can anybody guess where the Y components come from? The studs, honey. Yeah, look, the studs are going to be pushing upwards on the base of those rafters. And so the studs are talking about the Y components. And so, yeah, this is all one system. And we hope that it's all going to be one rigid system where rafters don't buckle and studs don't buckle and tie rods don't stretch. That's the ideal. All this stuff has got to work. And of course there's building codes to say, well, if all that's going to happen, the studs have to have a certain separation. And every region has its own standards and codes for how far apart they have to be to prevent compression or buckling of studs. Same thing with rafters. Same thing with tie rods. And if you do any major renovation or you build your own home or whatever, you got to look for that sort of stuff. And if you're looking at, malls or gallerias or cathedrals, look for this stuff. Because if there's internal tie rods, you're going to see it. If you look at the studs in a cathedral, and I was recently in England, I wasn't going around looking for studs, but what I did see was a lot of support columns. And don't they take on the role of the studs, in that context of building, right? They're everywhere. People have known about this stuff for ages. Anyway, your task, and this is going to come up in the homework, so I thought I should share it with you. Your task is to talk about some of this stuff and do some of these calculations. So I just wanted to rough out some of the language and how you would think through this structure and how it applies to the free body diagrams we're talking about. Really and truly, it's just all the same as some other problems we're looking at, but dressed up differently. Okay.